Hello and welcome to this class, Least Squares. There are a number of physical, economic, and social phenomena in which one variable is proportional to another. For example, Newton's second law says that the force F on an object of mass m is proportional to the acceleration a. Always say F is equal to m of a. And Hooke's law says that the force exerted by a spring, like this, the spring, is proportional to the distance it is stretched. Always say F is kx. Hooke's law is often given by F is minus kx, with a negative sign indicating that the force is in the direction opposite the stretch. For now, we will ignore the sign of the force. Manufacturing costs are proportional to the number of units produced. The number of traffic accidents is proportional to the volume of the traffic. These are models. And in the experiment, we will rarely find that the observed data fit the model exactly. Suppose that we observe the force exerted by a spring when it is stretched by x centimeters. For example, when we stretch the spring by 0.5 centimeter, we observe a force of 8 newtons. And when we stretch the spring by 1 centimeter, we observe a force of 17 newtons, and so on. This figure shows additional observations. And figure 2 shows a plot of the ordered pairs, xi, yi, where xi is a distance stretched, and yi is a force exerted on the spring. A plot of ordered pairs like this is called a scatter plot. Let's generalize the problem to one in which we are given n points, such as x1, y1, x2, y2, and xn, yn. Our goal is to find a line through the origin that best fits these points. To find the line that best fits these endpoints, we must be specific about how we measure the fit. Our best fit line through the origin is defined to be the one that minimizes the sum of the squared vertical deviations between xi, yn and the line y is equal to bx. If xi, yi is a point in the data set, then xi, bxi is a point on the line y is bx, that is directly above or below xi, yi. The vertical deviation between xi, yi and xi, bxi is yi minus bxi. Therefore, the squared deviation is thus yi minus bxi squared. The problem is to find the value of b that minimizes the sum of these squared deviations. If we define S as the sum of yi minus bxi squared, then we must find the value of b that minimizes the S. This is a minimization problem like the ones encountered before. Keep in mind, however, that the ordered pairs xi, yi, I from 1 to n, are fixed. The variable in this problem is b. We proceed as before by finding ds db, or finding the derivative of s with respect to b. Setting the result equal to 0 and solving for b. Since the derivative is a linear operator, we have the derivative of s with respect to b is equal to the derivative of this part. And this is equal to the derivative of yi minus bix squared. Then we take the sum because it's a linear operator. So we interchange the derivative and the sum. And by applying the chain rule, we have the derivative of yi minus bxi squared is equal to 2yi minus bxi times the derivative of yi minus bxi. And it's equal to minus 2, the sum of xi times yi minus bxi. Setting this result equal to 0 and solving it, we get that 0 is this part. And separate the two parts, we can get b. So b is equal to the sum of xi times yi over the sum of xi squared. To see that this yields a minimum value of s, we know that the second derivative of s with respect to b is equal to 2 times the sum of xi squared, which is always positive, and there are no endpoints to check. Thus, by the second derivative test, we conclude that the line y is bx with b is equal to the sum of xi times yi over xi squared is the best fit line in the sense of minimizing s. The line y is equal to bx is called the least squares line through the origin. Okay, now let's see one example. Could you find the least squares line through the origin for the spring data in the first figure? Now let's apply the formula we just got. So b is equal to the sum of xi times yi over the sum of xi squared. By plugging in the data, we will find that b is equal to the sum of xi yi over the sum of xi squared, and by calculation we will find that the result is about 1512.7. So the least squares line through the origin is therefore y is equal to 1512.7x, and is shown in this figure. The estimate of the spring constant is therefore k is this one. For most line fitting problems, it is unreasonable to assume that the line passes through the origin. A more reasonable assumption is that y is related to x by y equals a plus bx. In this case, however, the sum of squares is a function of both a and b. So we are faced with the problem of minimizing a function of two variables. This problem we will discuss in multivariable calculus. Alright, that's all for this section. Hope you enjoy it. Thank you. I'm looking forward to seeing you in the next class.